Okay, now that we've gone through and solved testing a claim about a mean using the p-value approach, we're going to come back and we're going to do the same, use the same stats outcrunch, but we're going to use it for now doing a critical value method assessment. So we're going to go back and we've got our test statistic that we have via stats crunch here. So our next step is going to be to go through and find find our critical values. Now to find our critical values, we're going to have to go through and use this information that we have here that we've already identified to find our critical values. So we have alpha here is 0.05 and we know our n is 61, right? And so if we go and we look at this in terms of our direction, remember we've looked at this before, so we're looking at a directional, when we're looking at this particular, we're going to have to go through and look at our hypothesis, and we can see here that using the alternative, now notice we're using the alternative, so that's the H1. When we look at the symbol there, that tells us what type of tail test we have and also the direction of the tail. So when we're looking at this, we see we have a greater than symbol in our alternative, which means we're doing a one-tail test and we're doing our right tail test. So you want to hold on to that second piece of information about a right tail test because we're going to use that as well. So now that we have all of these pieces of information, we're going to be able to go back and find the t critical values in your t distribution table. Now I suggest you use the t distribution table that's on the actual back of your textbook because it's going to have an additional little piece of information that's going to be really useful. So open up your textbook, or if you're working from the ebook, go to the last page that we're looking at there for our t distribution table, and we're going to use these two pieces of information to locate the correct column across the top. So you're going to go across the top and go, you're looking for a one-tail t-test, and you're looking at it for an alpha of 0.05. So that's going to give you the column. Then you're going to come down that column till you get to the row for degrees of freedom that correspond, for the number that corresponds to your degrees of freedom. So here we have our degrees of freedom equals 61. We actually don't have 61 in our t distribution table. We've got 60, so we're going to use 60 because that's the next closest value. And so that gives us a t critical value of 1.671. But we're not quite done yet. If the t distribution is a left tail, then your t critical value is going to be a negative value. If it's a right tail, then the t critical value is going to be a positive value. If it's a two tail, it's going to be both a negative value and a positive value. And remember, we're also going to have taken our alpha and divided it by 2. So remember, we talked about that previously in another video. So if you were doing a two tail for your t critical value, you'd have to take your alpha and divide it by 2. In this case, we're doing our right tail, so our t critical value is going to stay positive, so it's going to be 1.671. All right, and again, because we can see that with our alternative hypothesis of the greater symbol. Okay, so it's a right tail, means positive value. Now we've got our t alternative, right? So that's what we're looking at that we have from our actual data. Remember that t alternative, and I labeled as an A because I find it for the alternative because I find it confusing to have lots of different t's on the graph that we're about to draw, and I'd label my t a critical value. So I use those sub-levels for clarity. Now the next thing we have is to draw this out. So we've got to draw out our graph. And again, we've been doing versions of this all semester long, so this should start to be kind of familiar for us. So here we're looking at it. We've got our graph that we're drawing out. We're going to begin by drawing our distribution, and we're going to setting the mean of that t distribution is equal to 0. Remember, that is one of the properties of the t distribution. How do I know that that mean on my t distribution is always equal to 0? Because that's the property for that distribution. Okay, then we're going to draw out where our t critical value is in this graph in relation to our t equals 0. So here we see our t critical value is 1.671. So it's going to be to the right of the t equals 0. So you see I've drawn that out. And the next thing we need to ask ourselves is we need to shade in our rejection region. And this, when we're looking at this, we need to ask ourselves, looking at this distribution, are we going to be shading in the area to the right or to the left of our t critical value? How do I know which area to shade in? Okay, well, to help you solve this, you're going to want to look at the directional symbol in your H1 again. Okay, so if you look at your H1, you can see that you have a greater than symbol. It means you're going to be shading in the area to the right of the t critical value. Okay, Again, if you had a value there that was, my mean was set to being less than, then I would be shading the area to the left of it. If you need to, you can go back and look at the slides that we just looked at above that shows you the different graphs for a two-tail, a left tail, and a right tail. Okay, so what you draw out should to some extent resemble that as a sample graph. All right, so take another look at that if you need to. Now that we've got that drawn in, okay, I often find it's helpful to label exactly what I'm going to be rejecting if my test statistic, my t alternative, falls in the shaded region. And what we're going to be rejecting is, are we going to be rejecting our null, or are we rejecting all alternative? Is it going to be our HO or our H1? It's going to be rejecting the null hypothesis or our HO. And in fact, you may find it helpful to write out the specific terms of the null as well, as I labeled them right here. This is going to aid you later when you're doing your interpretation. Okay. Now, we're going to mark the location of our t alternative. And again, keep in mind that t critical value is what comes from the t distribution table that corresponds with our specific alpha that we have from the study. Okay, so our specific alpha, the direction of the test, and our degrees of freedom tells us what that t critical value is going to be. We're now going to compare the t value we got from our sample data or our test statistic and see how it relates to our t critical value that we have. So we need to mark in our location of our t alternative in relation to the other values on this distribution. So where is that going to go? Where does my t alternative go in this diagram? Is it going to go to the right of my t critical value or to the left? And you want to pay attention to the numerical values of these. So where is my t alternative going to go with this distribution? Well, it's going to go to the left. Okay, so we're going to mark the location for the TA. All right, and here we can see that it's to the left of it. Okay, because 0.819 is less than 1.671, so it will be between my t of equal to 0 and my t critical value of 1.671. All right, and so now here's my graph, and we're going to come back and do our interpretation. So now to assess our rejection regions. If the test statistic is within the rejection region, then we're going to reject the null. If the test statistic, my TA, is not within the rejection regions, then we're going to fail to reject the null. And again, the symbols I'm showing here for the T of A and the T critical value, I find those very useful notations instead of looking at a graph where I've got three different T's. I got my T equals 0, then I've got my T that's a critical value but it's still labeled T, and then I've got my T from my sample set but it's also labeled T. So I use these subsets of T subset CV to mean my critical value and T of A to represent the T value for my alternative, okay, from my sample. So if we're looking at these, does the T of A value fall within the rejection region or not? It does not fall within the rejection region, so we fail to reject the null for this particular test. Okay? And notice when you're looking at this, we get the same interpretation as if we did the p-value. This is another place where you can check yourself as you go along. The interpretation you get for your test with a p-value should be the same interpretation that you get with a critical value. If it's not, something has gone astray, and you need to stop, go back, and redo your work before you submit that question for grading on the exam readiness assessment, the exam. Because again, keep in mind on those, you don't get to check your work as you go along. So you make one mistake, it's going to affect everything all the way through. So making sure that your interpretation from your p-value and your critical value method are the same interpretation is a good self-check tool to use on your exam.